for testing the significance of the difference between observed and expected frequencies under the null hypothesis. That the difference is insignificant. Pearson has constructed the statistics chi squared equal to summation of O minus E the whole squared by E. Twice OI in general form OI minus EI the whole squared by E. And OI are the observed frequency EI are the expected frequency. Uses of chi-square test. Number one, it is used to test the goodness of fit. Of a distribution. Second one, is used to test the significance of the difference between the observed frequency and the expected frequency. Third, it is also used to test the independence of attributes. Procedure for testing. Significance difference between the observed and expected frequency. First form null hypothesis. There is no significance difference between observed and expected frequency. Null hypothesis. there is significance difference between observed and expected frequency. There is not. There is significant difference between observed and expected frequency. Test statistics. Chi squared equal to summation of O minus E the whole squared by E. And degrees of freedom, n minus 1. If calculated value of chi squared is less than table value of chi squared, H0 is accepted. Suppose if calculated value of chi squared is greater than the table value of chi squared, so H0 is rejected. For the testing the goodness of a distribution by assuming H0 as some specific distribution, binomial, Poisson, etc. We calculate the theoretical frequency and adopt the procedure given above to test whether the assumed distribution is a better fit for the observed frequency. Example, in 120 throws of a single die, the following distribution of phases was observed and phase and frequency one, 2, 3, 4, 5 and 6. Frequency 30, 25, 18, 10, 22 and 15. Can you say that the die is biased? Solution. First, assume null hypothesis. The die is unbiased. That means H1 alternative hypothesis, the die is biased. On the assumption H0, the expected frequency for each phase, so 120 throws, 120 into 1 by 6, that is 20. So phase O, E, O minus E, O minus E the whole squared. 1, 2, 3, 4, 5 and 6, 30, 25, 18, 10, 22, 15. So this one is 20, O minus E, 10, 5, minus 2, minus 10, 2, minus 5. O minus E the whole square, 100, 25, 4, 100, 4, 25. So here total 258, this total 120. Now statistics chi squared equal to summation of O minus E the whole square divided by E. That is 258 by the 20, 19 point. So degrees of freedom, 6 minus 1, 5. The table value of chi squared 5 degrees of freedom is 11.07. Conclusion: the calculated value of chi squared is greater than the table value. Therefore, H0 is rejected at 5% level. Hence, the die can be regarded as biased. Another example. The theory predicts that the proportion of beans in 4 given group should be 9:3:3:1 in an examination with 1600 beans. The number in the 4 groups were 882, 313, 287 and 118. Does the experimental result support the theory? Solution: first find the null hypothesis, that is the proportion of bean the 4 group are in the ratio 9:3:3:1. H1 not in the ratio, not in the ratio. 1. On the assumption H naught, the expected frequencies are 9 by the total 16 into 1600. 3 by 16 into 1600. 1600. Comma 3 by 16 into 1600. 1 by 16 into 1600. The 16 is 9 plus 3 plus 3 plus 1. 1600 examination with the 1600 beans. So ratio 3, 9 is to 3 is to 3 is to 1. That's why we are getting this expected frequency. That means 900, using calculator, 900, 300, then 300, 100. So O, E, O minus E, O minus E the whole square, O minus E the whole square by E. Observed frequency 882, 313, 287 and 118. Expected frequency 900, 300, 300 and 100. O minus E minus 18, 13, minus 13 and 18. The whole square 324, 13 into 169, 169, 324. So this value use calculator 0.36, 0.563, 0.563, 3.240. So here total 4.726. This total 1600. So statistics, chi squared equal to summation of O minus E the whole squared by E, that is 4.726. The degrees of freedom n minus 1, that is 4 minus 1, that is equal to 3. The table value of chi square is 7.81. The degrees of freedom 3. So conclusion, the calculated value of chi squared is less than the table value of chi squared. Therefore H naught is accepted at 5% level. Hence ends in the 4 group are in the ratio 9:3:3:1.